So hi everyone. To recap, last times we discussed that creating new threads is very bad for performance. So .NET provides for us thread pool where we can get our threads. We saw how we can schedule our work on that thread pool using both queue_user_work_item and task run method. We discussed tasks, how we can change them, and how we can change them using async await as well. We covered that we should never block the thread because there is no thread on IO bound operations. So whenever we have some IO bound operations, if we block the thread, we are essentially just blocking it for nothing. It's waiting and doing nothing. We discussed the difference between CPU bound and IO bound work. We also looked at some locking constructs to synchronize between threads, like, for example, semaphore LINQ for asynchronous code or just regular lock construction for synchronous code. We also looked at different thread safe collections that can be called from any thread without any fear of breaking the data. And we discussed blocking collection to create a producer-consumer model and its async counterpart channels, which allow us to create producer-consumer model without blocking any threads. So today we are going to cover parallel LINQ and asynchronous streams. Imagine we have some CPU-bound work that we need to run on as many threads as we can in order to use our CPU to the maximum. So, contrary to previous examples where we did not want to block any threads at all, and we want all our code to be completely as much asynchronous as possible. Here we want to use all our CPU to the maximum because we have CPU-bound work. So, for example, we are calculating something, or we are sorting some arrays, or reshuffling some data in some way, and we want it to be done as fast as possible. So we want to utilize all our CPU cores. For example, let's imagine that we can split our work into 10 parts, and each part will take 5 seconds. This is what, for example, parallel for method does. It creates a loop for us from inclusive, so from 1 to exclusive. So the last number that would be processing is 10. And then for each index, we can run some delegate. And this parallel for will run this delegate in parallel 10 times, from 1 to 10. The parallel for each and parallel invoke methods, they were initially created exactly for that purpose, to split CPU-bound work into multiple parts that are running concurrently, which is why by default it has the same parallelization as the number of your CPU cores. So if you have 16 CPU cores and you run 100 items using this method will still only split your work into 16 parts. So it will run 16 parts. Then after some of these parts are done running, it will pick up the next parts, etc. So it will run all your work, but it will parallelize it only into the exact number of parts that you have CPU cores. Furthermore, as you can see, this method is blocking. Is it not async? We cannot await it. It just blocks the main thread. So while this work is running, main thread is blocked and cannot do anything, right? Well, not exactly. Let's run this example, and I'll pause it before it ends. Let's go to parallel stacks window. So let me just flag my code here. As you can see, we have here 10 threads. However, we have only 9 worker threads running our code. Why is that? Because 9 of these iterations were picked up by thread pool threads, but the 10th operation is running by the main thread itself. So parallel for is smart. It knows that we are going to block the main thread until all these operations are done. So it also utilizes the main thread also to do at least one iteration of this work. So this main thread, it's not just blocking and waiting for all these operations to complete. It also runs one of these operations. However, yeah, if you have 100 operations scheduled here and one of them that is being run by the main thread is completed, then main thread will block and do nothing for the rest of all the other operations. So until all other operations will complete, main thread will do nothing because it already finished doing one operation and it doesn't start doing another operation. This is a way to schedule CPU-bound work to be run on all your CPU cores. However, you can also supply here a configuration option, parallel options. Yeah, parallel from index. Here. Parallel options. And in parallel options, you can always specify cancellation token to cancel the operation. If you need to task scheduler, we'll get to task schedulers in advanced meetup. But it's different way to schedule tasks, not just to thread pool, but for example, to some custom implementation or to your own synchronization context, etc. And max degree of parallelism. Max degree of parallelism says exactly to how many CPU cores we want to schedule this operation. Well, not to how many CPU cores, but to how many threads. Because if you specify this parameter and you say that it's, for example, 100, when you only have 16 cores, then PLinq will still try to run all your operations on 100 threads. And since they're all CPU bound, so they will block all the threads, thread pool will be starved and it will try to create all 100 threads with half a second debounce between each creation. So when you have a CPU bound work, never do that. Never specify here any parameters because even if your machine has 16 cores and you specify here 16, when you run this code on some pod or Linux container or something else, you do not know how many threads how many cores it has. So if it has only two cores and you have set here 16, a lot of context switching will occur and your operations will be slowed down because they cannot even with context switching, they cannot run faster than they can if they are CPU bound. However, if your operations are IO bound, and for some reason, instead of using regular tasks, you decided to use parallel for example, for simplicity, or you just quickly wanted to write some code that, I don't know, queries database or sends a network request 1000 times in parallel, then yeah, then be sure that to include here some parameter like 1000 or 100 in order for parallel LINQ to use more threads than you have logical cores. Because when the operation is IO bound, then on the contrary, you want to use your bandwidth channel to the maximum. And you don't care about threads because IO bound operations generally do not use any threads. So they will all 100 operations, they will use a thread for like a couple nanoseconds to schedule something or to set some event or to signal some device driver, and then they will return the thread to the thread pool, and another thread will be able to reuse, another operation will be able to reuse that thread. Why it's important to set it for, well, for CPU-bound operations, you do not need to set it. Then it will be optimized for specific CPU. But why it's important to set it for IO-bound operations? Here's a case from a real project. We had implemented some logic to get the data from external source. And it was really slow. So the service was timing out actually on the startup. And Kubernetes would restart it many times in a row without even giving it a chance, because it took more time to start. It took more time to start than Kubernetes allowed for timeout error. So Kubernetes would restart it, and essentially the service would never start. The quick fix for that was to introduce this parallel loop. It was actually for each and not for SA, if I remember correctly, but it doesn't matter. The issue is that it ran perfectly on the local machine. It like executed in mere seconds, and everything started up, right? But during the release, it turned out that on the remote machine, it still timed out. Because, well, on our development machines, for example, there were 16 cores, so it paralleled it into 16 parts. But on the Kubernetes cluster, there were only 2 cores. So without specifying this max degree of parallelism, it was still almost as slow as just doing it sequentially. It was just speeded up in by 2, because only 2 operations were running at the same time. So another fix for that was needed, and we increased that max degree of parallelism to some specific value. Now, there is also a parallel for each method, which does exactly the same, but it goes through some element in an array or some collection, enumerable. And you have an element here instead of index. For works slightly better than for each by internal implementation. So if you can use for, I prefer using for. And there's a third method also from parallel static class. It's invoke. Invoke just runs your delegates that you manually specify into invoke as a params action. Yeah, and it also runs it with the same configuration. So make sure to include it if you need it, like max degree of parallelism, to specify it if it's input-output operations, or you can skip specifying it if it's pure CPU-bound operation. If any of these methods or these methods or these methods throw an exception, then the exception is also instantly thrown from the main thread when you call parallel for each. So if you need this loop to still work, if any of your delegates throw an exception, make sure you include everything inside the delegate into try catch and log the exception instead of throwing it. Also note that this is always an overhead. Parallel for, it creates for you some tasks, it runs them in parallel, it creates some other constructions and allocates them. So if you have a very, very fast loop and you need just run them in, I don't know, sequentially or in parallel, and it really executes very fast, it might be faster to actually just execute it sequentially and not use parallel for. So this is used for long running operations. But by long running operations, I mean like maybe half a second. So half a second is already kind of long operation. By fast operation, I mean mere milliseconds. So if you have some couple milliseconds for one operation, then maybe it might be better to just run it sequentially. So yeah, then when you run this loop, sometimes you need to orchestrate the execution of all the other instances of your other delegates from some one delegate. For example, you want to stop running all these operations as soon as fifth operation has already been run. These methods, they also provide you a state parameter that you can specify together with an index, which will be available in your delegate. And this state has various properties that you can inspect and various methods that you can use. For example, here I'm checking if the property should exit current iteration is true, and if it is true, then I'm not doing anything. And later, if index is more than 50, then I call a method stop. This method stop on the state, it will set should exit current iteration to true for all the other new operations. So if, for example, this for runs concurrently first, second, and 50th operation, because it's concurrent, so it might run 50th just on like the third operation. Then I'll have it as stop, and third, fourth, 51st, 55th, all the other operations will not execute at all, they will just exit. Also, there is a method, the lowest break iteration, which tells you on which iteration you called this break method. So you can call a break method on some iteration, and then this lowest break iteration will be set, and then you can inspect it and do something also inside your inside all of your delegates. This way you can orchestrate if you need some more complex orchestration between your parallel operations. Also, if any of your other delegates through an exception, you can inspect state is exceptional property. There might be more properties. I included here just some couple basic ones just to show you that you can always orchestrate it if you need to. Now, separately from parallel class, there is such thing called PLinq, which means parallel LINQ. So everyone is familiar with LINQ. When we have some collection, we can use some methods like take, which will take only 16 records. Then we can use select to transform this record into some other record. Then we can use to length select, we can use where, and then to list, etc. These are all methods of LINQ that just generate enumerables from another enumerables, which allow us to write the beautiful code like this in a functional manner. However, what if one of the selects is performing a very long time? For example, here I'm transforming a book and I'm changing its title property into a hashed title property, where this hash title method is sleeping for 2 seconds before it's hashed. This is an imitation of, for example, getting to the database to get some certificate, etc. So let's imagine it takes 2 seconds. And we are doing that for every book. So we have 16 books, and for every book, we are waiting for 2 seconds. Since this select is sequential, then we'll wait for 2x16 for 32 seconds, for more than half a minute. However, PLinq introduces this method for us as parallel, which converts a regular enumerable into parallel query. And this parallel query, it also has all the LINQ methods that we can use further, like select, where, etc. But all these methods that we are calling on the parallel query, they are going to be executed in parallel with each other. So in this case, all 16 books, they will be run in parallel. And so this all the books, all the hashes will actually compute in just 2 seconds, because all 16 of them will execute at the same time and will run for 2 seconds each. However, as parallel, it doesn't preserve order, because it just executes in parallel, and the result after this execution will be unordered. If we need to order it, there is also additional method asOrdered. If we need to stop ordering it, because ordering also incurs some performance overhead. So for example, later we have another select, but we already do not care about ordering in the next select. We can always get it back into as sequential. Into as unordered. Also, if we want to run this query, some query later, like where, without parallelization on the regular enumerable, we can also use method as sequential, which will transform the query back into original enumerable. It's similar to the methods as curable and as enumerable, to transform enumerable to curable and back. And also, as parallel has different configuration options, as well as parallel for. It has this degree of parallelism, so we can set specific degree of parallelism. If we set here 6, then these books will only be hashed by pairs of 6. So 6 books will be hashed in 2 seconds, then the next 6 books will be hashed in 2 seconds, etc. So it will not take 2 seconds, but it will already take more than 2 seconds. And there is also this merge options parameter, which allows us to configure buffering. So by default, it's auto-buffered. The PLinq decides automatically how much buffer it needs to have. However, if we have a lot of memory and we care about performance, we can use all the memory we have and use fully buffered. Then the whole query will be fully buffered in memory. If we, on the contrary, do not care about performance, but we care about memory, we have very little RAM available on our machine and we want to not use it, then we can specify not buffered. Then no memory will be used for buffering of these queries. And another option is with execution mode. Execution mode is either default or forced parallelism. Thing is that sometimes, not in the case of the thread sleep, of course, but sometimes it's faster to execute some queries sequentially, contrary to executing them in parallel. So PLinq is smart enough to analyze this and decide, okay, I want to execute this sequentially because it will be faster. This is what default option does. If you force parallelism, then they will always be parallel. All the queries that you write after is parallel, they will always parallelize into your configuration, like 6 threads, for example. Unfortunately, though, let's imagine we want to unblock the thread, right? This hash title, it's currently synchronous, and we are sleeping here. We are blocking the thread for 2 seconds. So if we run this query, it will take all 16 books and it will block all 16 threads. Thread pool will be started. Unfortunately, we cannot have here something like select async or something like that. PLinq doesn't work with asynchronous code. So yeah, this is because it was initially created for CPU-bound operations. So if you have CPU-bound operation, you need to use your CPU anyway. But if you have IO-bound operations, yeah, you will not be able to await here anything in that select, for example. We'll see a bit later how we can work around it. So one second. So yeah, let's now discuss asynchronous streams, switching the topic a bit. What is asynchronous streams? Well, I remember the time when we could write a generator, like for each some item, right? Like this. we are returning a enumerable of books, and inside that generator, for example, in while true, we are yield returning new items. So this will create a pure generator that just returns books forever. We can do that with yield keyword. However, we never could return it asynchronously in the past. We could either yield return new book, or we could return like task enumerable book. But if we return task enumerable book, we needed to completely create that enumerable already existing in the memory in order to return it in a task. Well, new.NET introduced, well, already kind of old .NET, but on the time when it was introduced, it was a new.NET, and it introduced new thing. It introduced async enumerable. In other words, it's called asynchronous stream. So if you see in any documentation anything about asynchronous streams, people just mean async enumerable. This asynchronous stream, it allows us to do exactly just that. It allows us to use yield keyword inside our generator. It creates a generator. But inside our method, it can also be marked as await and async, and we can use await constructions. So it works like any other generator. As soon as you try to iterate over this async enumerable that is returned by this method, iteration will start executing our code, will first of all be able to await any operations without blocking any thread, and then as soon as we reach the first yield, it will return us this item, and then after we wait for the next item, it will continue executing, we'll await another operation, etc. Since we are awaiting every operation before some item is returned to us, we also need to await this async enumerable. How it's written in the code, it's written like this. New construction, not just for each, but await for each. Await for each makes sure that before getting each item, we are awaiting that operation inside the async enumerable. And we can obviously use any kind of LINQ queries on async enumerable as well. So for example, here I'm taking just the first 10 items. And as you can see, this take method also returns us async enumerable. So I'm getting 10 first items from this generator, and I'm using await for each to iterate over them. This is how, in essence, async streams look like. They're using value tasks under the hood, so they are very performant. If you do not have any awaits here, or if all your awaits are already on completed tasks, then the value will be returned completely synchronous without allocating any additional tasks on the heap. So even if you have completely synchronous loop, but you are returning async enumerable, it's gonna be performing as fast as just the regular enumerable. This is an example of how this async enumerable can be used in order to get data from the database, actually. So imagine we want to give user an access to an enumerable of the books, which he can then iterate over to get either all the books or 10 first books or like maybe 100 books. We do not care how much he wants to get. However, in our database, we have 1 billion books, so we cannot return all of them, or we'll run out of memory, or time out because when user will be trying to get them all, the operation will just time out. So what we can do instead is this kind of paging. This is an example of paging based on async enumerable. So in while true, we are checking that it's the first iteration. If it's the first iteration, then, for example, we are getting the next page. It's just a simulation of getting the next page from the database. Let's imagine we are getting just 3 books, and it takes 1,000 milliseconds. After this operation completes, we are incrementing the I, and we are returning the book that we got from the database, from some list that we get here, for example. So on the next two operations, we will not run any asynchronous operations at all. We'll just return a second book, then we'll return a third book, and only then, after the third operation is reached, we are resetting our counter in order to get the next page. So we're getting the next page, the next book, book 4, 5, 6, and then we are starting returning them. It all happens under the hood because we have async enumerable and all the await code here, but the user just has an enumerable to work with. So he can just iterate over it, write some LINQ queries on top of it, and await for each. If we need to cancel our async enumerable, we can always, when we generate that async enumerable in our method, we can always pass here a cancellation token, right? Because this cancellation in .NET is cooperative pattern, so we need to pass cancellation token to the methods that generate async enumerable, and we need to cancel it in some of our code. For example, here we are canceling it whenever we need to get the next page, if the token requested cancellation. Here is how we can just pass it into this method. Also, we can always use configure await as well as on tasks and value tasks. We can also use it on async enumerable because async enumerable is also awaitable. So if you're using it in some library code, then do not forget to call this configure await that we need to call everywhere, especially in the library code, in order to not introduce any bugs. But let's imagine that somebody else creates this async enumerable for us, and we just need to cancel it. So imagine this example. We create async enumerable, which somebody else created for us, and pass here some cancellation token from external code, or maybe even not pass it like here, just default. And we just have a reference to this variable. And we want to iterate over it, but we want to cancel it. .NET provides with cancellation methods for this, where we can pass our own cancellation token. And later, when we cancel it, then the operation will also be canceled. So this cancellation token inside this method, it will actually be linked between the cancellation token that was passed initially into this method and the cancellation token that was passed into this with cancellation parameter. However, it will only be linked and it will only work if the implementer of this method that created this async enumerable added this magic attribute here, enumerator cancellation. So whenever you create your own async enumerables, also add this attribute enumerator cancellation to your cancellation token parameter, so that later consumers of your enumerable will be able to use that with cancellation method. Because if they use it and you did not supply this attribute, it will do nothing. And returning to channels example that we discussed on Friday, I just wanted to remind you that here in the channel there is an additional method on the reader, read all async. And read all async method, it creates async enumerable for us. So instead of just using reader read async method, like we used here to read the next book in cycle while true. Instead of that, we can just use await for each and iterate over all the items inside this channel reader read all async method, which will return our async enumerable. And whenever somebody pushes something into using the writer into our channel, we'll have the next item available here. But until that, await for each will just await without using any thread as completely non-blocking operation. It will just await until the item is available, and then it will let us process it. Now, here we have we get async. Yeah, and in async streams, this is our async enumerable. I just wanted to show you that on async streams, we always can use all our LINQ methods that we are used to be using, like take, var, select, order by, etc. We can all use them on the async enumerable. Now, imagine we have this code. We have our generator, which is generated using our, like, it's async enumerable. It's absolutely the same method like in previous examples. It just gets the next page every 3 items for 1 second. So it's an async enumerable. We can wait for each of it. And we take 10 items, we filter some authors, and then we select. And for every book, we run this method, hash title, which, as you remember, sleeps for 2 seconds. So it blocks current thread. And if we take 10 books, then it will be blocked for 20 seconds because it's completely sequential. It's like processing one book, then process another book, then process the third book, and it takes 20 seconds. Furthermore, it will, for these 2 seconds that are running this operation, it will block some thread of thread pool. Well, basically main thread of thread pool. It will block it because the select is completely synchronous operation, even though it is being run on async enumerable. Can we somehow fix this? Well, for that, we have a separate package called Async LINQ. Yeah, there is a package called Async LINQ that provides for us these kinds of operations. It gives us operations that can have func delegate that returns task. So these operations are asynchronous and can be awaited. So in this case, we are, instead of using select, we are using select await that accepts func task, where we are awaiting our hash title async operation, which I have rewritten to instead await task delay. So it doesn't even block any thread right now. And this operation will not block any thread at all. It will just execute without using threads. However, there is still one big issue. These selects will execute sequentially. It's not a parallel. It's not like PLinq or parallel for each or parallel for. It's just a select. It's just now that it doesn't block any thread. But we still have 10 books, and these selects will execute one by one. So first one book will be converted into the hash, which will take 2 seconds without blocking any thread, but it will still take 2 seconds. Then another book will be converted to the hash, which will take the next 2 seconds. And so it will take 20 seconds. So here in this await for each, we'll write to console every year that we got here. And we'll get every item only once per 2 seconds. So actually, I can even show it. It will not block any threads, but it will still produce only one item per 2 seconds, as you can see. So can we somehow improve it? First of all, before talking about how we can improve this, to combine it with some kind of parallel LINQ, etc., I wanted to discuss this library a bit more, the Async LINQ library. It provides for us methods like select await, and it has some conventions for method naming conventions, so we can understand what this method is doing. Whenever the method is ending with await word, it means that the delegate inside it can be awaited. So you can run some asynchronous code inside the delegate. But the value that it returns, it's a synchronous value. So in this case, it is async enumerable string. So it just returns as a string. This method, after awaiting, it will return as a string. There are other kind of methods in this library. For example, some async. Contrary to await in the select await. The end of this method is named async. Async means that the delegate that is passed inside the sum async is completely synchronous. As you can see, there are no async awaits here. I'm just getting the length. However, the operation itself, it needs to be awaited. So it doesn't return async enumerable. As you can see, it returns value task int. So it just returns a task that will have a result of int. We need to await it to get that result. So this sum async, it will just sum all the items in our async enumerable, but it will do this asynchronously. So if on our LINQ chain we have some other asynchronous operations, it will not block the thread during that sum operation. And there are also methods that both have await and async. So in the case of sum await async, it returns us, since it's async, it returns us just value task int. So it will be a sum that will be returned after we await this operation. But since it's also await, then inside it accepts delegates that can be awaited. So we can run this delegate inside that will, for example, wait 1 second and only then return length. And we can also await this operation in order to sum all the items. So there is where await, select await. So there are all kinds of different operations with also await and async prefixes to use in that library. So whenever you need to run some LINQ on some async enumerable without blocking any threads, consider using async LINQ library. Now, in the past, here we parallelized our query in order for that hash title to be executed in parallel. And in our async streams examples, we used async LINQ to just not block the thread. But in async LINQ example, all these items were selected sequentially. So can we somehow combine parallel LINQ and async LINQ together in order to run some operation in parallel and also asynchronously? The answer, unfortunately, is no. Parallel LINQ does not work with asynchronous operations, so we cannot use parallel LINQ. However, we can try to come up with some ad hoc solution in order to do that. And I have example just for that. So here's an example. Let's go through it. This is an example of parallel LINQ. We have books. We take 16 of them. We go as parallel, and we get the hash. It works as parallel. It's all cool, but it blocks 16 threads because it will go and use 16 threads and block them with this method for 2 seconds each. Second example is our async example. We convert it to async enumerable. We take 16 books, and instead of as parallel, we are using select await on our async enumerable, which will not block the thread, but it will run all 16 books sequentially. So it will take 20 seconds to run it all. This is a combined example that I tried to make it work. So what I'm doing here is I'm taking 16 books, then I'm using a regular LINQ select, But for every book, I create a new task. Yeah, this is my workaround. I create a new task in which I am awaiting that operation. So now here I create 16 tasks that will be run on and delegated on the thread pool whenever some thread is available. And they also will not block any threads, by the way, because this hash title async internally uses task delay, so it will not use threads. After the select, I convert this enumerable to async enumerable. And on this async enumerable, I use async LINQ method select await, which just takes each task created from this method and awaits it. So this operation essentially converts iAsync enumerable task book into iAsync enumerable book. So it just gets rid of that intermediary task object. And now we can just use await for each and run through all our books and write it into the console. As an example, this is how it looks like. It should work, I guess, very, very fast without blocking any threads. Yeah, okay, something's wrong here. I guess, well, not to spend time because we have only 10 minutes left, I'll look into it a bit and we'll fix whatever is wrong here. And we'll discuss it on Wednesday. But yes, the general idea is this one. I think it was working when I was testing it, and just probably I was just too fast to try to run it, and something is still not working here. But yeah, the general idea is we just create new task, convert it to async enumerable, and await each task. Yeah, because we are waiting each task, this thing is blocking us. Because when we await each task, it's happening sequentially. It's happening completely sequentially. So yeah, we cannot do it, unfortunately. Unfortunately, we need to, instead of using a async LINQ, we need to do it old-fashioned way. Something like task when all. So we just need to get this async books and create a new task from then when all and await it. Something like this. Then we'll be able to run for each on all these books. Not even await for each, but just regular for each. Yeah, this would work, but it's not as cool as I thought it would look if we use async LINQ, but I guess async LINQ is really doesn't work here. So my initial, as you can see, yeah, my initial proposal to kind of combine LINQ and async LINQ didn't work. So yeah, we cannot use PLinq with async code. Now let's look into two more libraries before we wrap up this meeting. There are two more libraries to manage asynchronous flows in .NET. One of them is System Reactive. It's a different way to manage asynchronous code. System Reactive provides for us some reactive primitives that we can use, and they work kind of like events. So in this example, I'm just showing behavior subject object, but there are many different objects like timer, which produces a value every second. And there are also extension methods that convert all your enumerables into these objects that produces values. But for example, behavior is subject is an object that has some initial value. This is an example of initial value. And it has some type which it will produce. And later, we can subscribe to this behavior subject. And subscribe accepts a delegate that works on that item. It does something whenever a new item is pushed. And in background, as you can see, I'm just running a loop, which every second it creates a new title and it pushes 3 new books. So subject also has method on next, which pushes a new book into that subject. It's similar to consumer producer model we saw on channels or on blocking collection. But system reactive is much more powerful because it can, first of all, you can subscribe many times from different places of your code whenever you need that value, and whenever somebody pushes a new value, you'll have this code being run. And second, system reactive has additional methods to filter on that subscription. So you can get, for example, only books when a book contains some name, etc. So this is an example of just a couple of methods that you can use. We can, on the subject, use select in order to, for example, get only title of that book. We can filter it only when title is not initial, so that we are filtering our initial book and will only get the ones that are pushed later. But this is a bad example because if you do not need initial value, just use subject. There is a separate object subject, not behavior subject, but just subject. It doesn't have initial value. So there are a lot of different objects, not just behavior subject. We can skip 3 first books using skip. We can throttle all the books. So if books are coming faster than in half a second, we will not get a single book until at least one time passes between pushing new books where time is more than half a second. We can also use distinct until changed, which will not produce any books for us in our subscription if these books are completely the same. So all these 3 books will only emit one console write line here because they're all the same, and this distinct until changed will check that they're all the same. We can also use take while, which will run this subscription until that condition happens. And if it happens, it will unsubscribe you. So this thing will be unsubscribed. You do not need to care about disposal, and that thing will never be called again. If whoever's here is familiar with Angular framework in frontend or RxJS library, well, this is exactly the same as RxJS library for JavaScript, TypeScript. Actually, the same team is implementing them. There are different libraries for different languages with the same concept. So for TypeScript, it's RxJS. It does absolutely the same. For .NET, there is System Reactive. There is also a library for Java, and I think even for Go, though I'm not sure. So for a lot of different languages, there is a website like System Reactive or something like that, reactive extensions, where you can see the total list of all the languages for which this library is available. In my experience, I used it once in my life in desktop application where we needed some reactive behavior. So I would say that this library is great for use case of desktop applications because there it really shines. Or some applications where you need to update some data reactively. It's no wonder that in Angular that use this library for updating templates on your web pages. However, I'm not sure that it's very useful in server-side applications, considering that we have all the other possibilities to use channels, async streams, and many different things. And the last library that I wanted to cover is data flow. Many of you might be familiar with it because it's rather old. Data flow is a library that allows us to create some blocks, like here action blocks that will also run some delegate whenever some item is coming into this action block. And in order to send the item to this action block, you use method post. So this to method post hello post world will just write hello hello and then world world. You can also complete the block to stop posting anything into it. This will not do anything because complete has been already called. And there are different kinds of blocks which you can change. For example, here's one action block, another action block. I create a broadcast block and I link broadcast block to both action blocks. Then I post something and this post will come to broadcast block and then it will broadcast it to both action blocks and these both pieces of code will be run. With Dataflow, you can create complex meshes of logic that will flow through different data blocks and will execute different pieces of logic. Whenever you have a complex mesh, then yeah, I think that Dataflow library worth it. However, if you just need to use some producer-consumer model, in the past I used TPL Dataflow for it. However, now that we have channels, I'd say that the first class citizen for producer-consumer model is channels. It's faster, it's more modern, it's basically a better alternative to CPL Dataflow whenever you need to just have producer-consumer model. Dataflow shines where you need to have some really complex mesh of blocks chaining one into another, and you need to process data in a specific way, like this. So, does anyone have any questions? All right, if nobody has any questions, I'll share you as a bonus. Not because nobody has any questions, a bonus, just a bonus because it doesn't go into this topic of our discussion for now. Just I would prefer that everyone have questions, to be honest. So I just wanted to show you another object in .NET that also helps us to create some thread-safe stuff. It's lazy object. Many of you probably know about it. Lazy class just allows us to create a new instance of some singleton that will be created only once. So if, for example, we create a new lazy, we pass as a generic parameter the object that we need to create, and inside that lazy we pass our method that needs to be run in order to create this object. So we pass the factory method. And later, in order to get the value of the lazy, we just write lazy.value. However, if we do it in many threads, for example, here I'm using parallel for, and in 10 threads in parallel, I'm just getting the lazy value. It will still be called only once. So from however many threads we call this lazy value, it will only be created once, and for all the other threads, the already created value will be returned. So here you can see we have a console write line creating a book. If I run this example, you'll see that it only wrote creating a book once. And if I press enter here, you'll see that after read line, we do it again, and creating a book is not called at all anymore because it's already created. So this is a very simple and easy way to make sure that your initialization logic has only been run once. Lazy also has lazy thread safety mode configuration options, which by default is execution and publication, which means that it internally uses some kind of locking in order to ensure that the logic is run only once. However, if you set it to none, then this lazy will be not different from just creating a new book without any lazy, because it will be completely non-thread safe. And if you use publication only, then it will allow multiple threads to run this method multiple times. Let me just run it, not to lie to you. Yeah, as you can see, this method has been called many times, but any other new threads that will access this value after it already has been created, they will get already created value. And also all these threads are getting the same value. So it's just that they are running this method. Each of them is running this method. But after it has been run, the first thread that sets the value, it will set the value. All the other threads will get the same value. So it's kind of like multi-thread safe, but you're still getting this method executed many times. But if your method is very fast executing, and if your method is very fast executing, but you have a lot of threads that access lazy during initialization, then maybe this is a faster option, because it might be faster to run very, very, very fast method multiple times than to use default execution and publication mode, which will internally use locking inside lazy to ensure that this method is called only once. All right, I guess this is all I wanted to cover today. I'll just...
Sorry, Ivan, can I add something?
Yeah.
As far as I remember, previously, before lazy was introduced, we've been using double check pattern also with locking.
Yeah. We were using double check pattern. Double check pattern means something like this, right?
Yep.
Yeah, this is a pattern to create some cached value that you have to cache. Obviously, it's still a very good pattern, and we need to use it whenever we need to have some cache value. But yeah, lazy is just a faster way to whenever we need to have just some singleton. It's just already pre-made class for us, and the locking that it performs inside is probably more optimized than using a custom lock.
Yep, thank you.
Anyone else? Does anyone have any questions about any of the topics so far? Well, if not, then thank you for joining, and I'll see you on Wednesday when we cover some more advanced topic and performance optimizations.
Thank you.
Thank you.